Let's read the question. The Van 't Hoff factor I for the dilute aqueous solution of HCN 10% dissociated is. Student, this is a very easy and a very important question. In this question, we have to calculate I, that is Van 't Hoff factor, for HCN, for which we are given with alpha, that is percentage dissociation, which is equals to 10%. So first of all, I'm writing the formula to calculate I. I is equals to 1 plus n minus 1 alpha. For HCN, n is equals to 2, as HCN dissociates to give H plus and Cn minus. So the value of n is 2, and also we are given with value of alpha, that is 10%, which is equals to 10 upon 100, that is 0.1. Now we can calculate I. 1 plus n is 2 minus 1 alpha is 0.1, which is equals to 1 plus 1 multiplied by 0.1 will be equals to 1.1. That means the correct answer is option number 4. Moving to next question, students, which is question number 52. Let's read the question. Which of the following does not depend upon temperature? Students, here we are given with some concentration terms and we have to identify that which will not depend upon temperature. And for that we need to know that if the concentration term depends upon volume or has volume term in it, will depend upon temperature, as volume changes on changing temperature. So let's start with the first option, molality. Student, molality does not has volume term, therefore it won't change on changing temperature, or we can say that molality does not depend upon temperature. Same with mole fraction and same with weight by weight percent. All the given three concentration terms will not depend upon temperature. That means the correct answer for this question is option number 4. Moving to next question, students, which is question number 53. Let's read the question. A solution of urea, molar mass 60 gram per mole, has been prepared by dissolving 6 gram of urea in 500 gram of water. The depression in freezing point of the solution obtained will be. We are also given with the value of Kf, that is cryoscopic constant for water, which is 1.86 Kelvin kg per mole. Students, in this question, we have to calculate depression in freezing point. We are given with the mass of solute dissolved and the mass of solvent. We are also given with the cryoscopic constant of the solvent. So let's start. First of all, I'm writing the formula to calculate. Delta Tf, which is depression in freezing point, is equals to I multiplied by Kf multiplied by molality. First of all, the solute given is urea, and for urea the value of I is 1, and for water the value of Kf is 1.86 Kelvin kg per mole. We only have to calculate molality and then we'll be able to calculate the value of delta Tf. Molality is equals to number of moles of solute upon mass of solvent in kilogram. For number of moles of solute, we are given with the mass of solute and the molar mass of solute. So it will be 6 divided by 60, and then we have to divide the entire term with the mass of solvent in kilogram, which is given as 500 gram. So we have to convert this into kilograms. So we'll multiply the numerator by 1000. Now let's calculate the value of delta Tf. It will be 1 multiplied by 1.86 multiplied by 6 upon 60 into 1000 upon 500. Student, we have to multiply all the terms and divide the terms, and the value will be 0.372 degrees Celsius. I have multiplied this. You people will multiply. And that means the correct answer is option number 1. Moving to next question, students, which is question number 54. Let's read the question. Which of the following relation is correct? Students, in this question, we are given with the relation between ln K and E0 cell. For this relation, first of all, we have to write Nernst equation. So I'm writing it. E cell is equals to E0 cell minus RT NF ln Q. Since here we are given K, that means the reaction is at equilibrium. So at equilibrium, Q will be K and E cell will be 0. So let's put the values in the Nernst equation. 0 is equals to E naught cell minus RT NF ln K. Let's further solve the equation. E naught cell is equals to RT NF ln K. So ln K will be NF E naught cell upon RT. That means the correct relation expressed in option number 1. Moving to next question, students, which is question number 55. Let's read the question. Limiting molar conductivity of CH3COOH, that is acetic acid, is equal to. Student, for this question, first of all, we need to know that limiting molar conductivity of CH3COOH is equals to limiting molar conductivity of CH3COO minus plus limiting molar conductivity of H plus. Now students, we are given with some compounds. First is sodium acetate, that is CH3COONA, then NaCl and then HCl. So using the limiting molar conductivities of these compounds, we have to calculate the limiting molar conductivity of acetic acid. So limiting molar conductivity of CH3COONA is equals to limiting molar conductivity of CH3COO minus plus limiting molar conductivity of Na plus, and then limiting molar conductivity of NaCl is equals to limiting molar conductivity of Na plus plus limiting molar conductivity of Cl minus, and then we have limiting molar conductivity of HCl, that would be equal to limiting molar conductivity of H plus plus limiting molar conductivity of Cl minus. Now student, mark this equation as 1, this as 2, this as 3. We want limiting molar conductivity of acetate ion and H plus ion. That means we have to add equation 1 and 3 and subtract equation 2. So this Na plus would cancel this Na plus and this Cl minus would cancel this Cl minus. As a result, we'll be left with limiting molar conductivity of CH3COO minus plus limiting molar conductivity of H plus, which is further equals to limiting molar conductivity of CH3COOH. That means adding equation 1 and 3 and subtracting 2 would give the final result. So limiting molar conductivity of sodium acetate plus limiting molar conductivity of HCl minus limiting molar conductivity of NaCl would be equal to limiting molar conductivity of acetic acid. That means the correct answer for this question is option number 4. Answer is option 4. Moving to next question, students, which is question number 56.